Welcome back to our series on matrices. Today we're talking about how to solve a system of equations using matrices. If you've missed any of our previous videos and matrices are new to you, I recommend you go back and take a look at those and then come back and join me for systems. In this first problem, we have a 2 by 2 system of equations. The 2 by 2 refers to the number of equations and the number of variables. But what we're going to do is take those equations and rewrite it as a matrix. Then we can use matrices to solve for any variable we need. So for instance, we have here 3x plus 4y equals 7. In the first row, we use the coefficients 3 and 4 from the x and the y. And then the last value is our total. I did the same thing for the second equation. 4x minus 2y equals 5. And before I go any further, I just want to make a note. Notice how I lined up all my x values, all my y values, and then my totals. It is imperative that you do that whenever you want to use a matrix to solve a system of equations. Now let's solve it. We're going to go into our calculator, second matrix, go over to edit and press enter. We have a 2 by 3 matrix, 2 rows, 3 columns. And now we can enter our values. 3, 4, 7, 4, -2, and 5. Now, we're going to use this operation right here. Second, matrix, math, and then RREF. RREF stands for Reduced Row Echelon Form. The name really isn't that important. It just needs to know that you use it to solve a matrix. So let's go ahead and do that. Second, matrix, go over to math. I recommend scrolling up. RREF is generally towards the bottom, so scrolling up will be a little faster. Press enter. And now we're going to go back in and select the matrix we created, which was matrix A, our 2 by 3. Press enter and then enter again. As you can see on my calculator, I have a lot of decimals, and that can get pretty messy. So just like any other decimal in our calculator, we can convert these to a fraction. Press math, and that first option, this will rewrite everything in the matrix as a fraction. Press enter, and there we go. So we're going to rewrite our matrix. We have a 1, 0, 17 over 11, 0, 1, 13 over 22. Now I'm going to point this out because this is extremely important. When you have a solution to a system of equations, it will always look the same. You will have a diagonal of 1s, and then you will have a triangle of 0s. Oops. There's my triangle. Here's my triangle. Now, the values on the far right side are your solutions. So its setup is similar to what we had before. Here are my coefficients. Here was my total. Here are my coefficients. Here is my total. And remember what I said earlier, lining up your variables is important. That means this 1 represents, and I'm going to come down here and write it, 1x plus 0y equals 17 over 11. We don't generally write a 0 with a y, so our answer is x equals 17 over 11. And then our second row, same thing, 0x plus 1y equals 13 over 22. And again, we can drop that 0, and we get y equals 13 over 22. And then our solution, just like any other ordered pair, 17 11s, comma 13 over 22. And there's our solution to our system of equations. Matrices makes everything easier. Let's try one more with slightly more problems, or variables. Here we have a 3 by 3 system of equations. Let's go ahead and rewrite our system as a matrix, row by row. So 2, 1, -2, -1. 3, -3, -1, 5. 1, -2, 3, and 6. We have our matrix ready to go. We can go back in, second matrix, and we're going to go over to edit, and then down to option 2, because we already have a 2 by 3 created for matrix A. We're going to make a new one, matrix B, and this is a 3-row, 4-column matrix. 2, 1, -2, -1. Next row, 3, -3, -1, 5. And our third and final row, 1, -2, 3, 6. Second matrix, math, RREF. Let's go back to second matrix, scroll over to math. We're going to scroll up for reduced row echelon form, and then we're going to select matrix B. And there's our solution matrix. We have 1, 0, 0, 1, 0, 1, 0, -1, and 0, 0, 1, 1. And I'm going to draw that vertical line again because I think it helps us to see that we have that diagonal of zeros, right? A diagonal of ones, beg your pardon. And over to the side there's my triangle of zeros. And up here, my triangle of zeros. So that means I have a unique solution. And remember, x's came first, then our y variables, and then our z's. So in that first row, we have x equals 1. Second row, y equals -1. And in the third row, z equals 1. And we write our solution similar to an ordered pair. 1, -1, 1. Listing our numbers in alphabetical order by variable. Interested in seeing what infinitely many or no solutions look like? Watch the next video.